Okay, so can we start with the session? Anyone has anything to say? Does anyone want to ask anything?
No, ma'am. Good evening, ma'am.
Good evening.
We can.
Okay, so this is the first question. Just give this question a try and then we'll do it here. There's just some functions and then you have corresponding graphs here. So you have to match them with the graph uh, and their tangent at 0, 0. That's all. And when you're done, you can just drop your answers in the chat box. No answers so far. Are you guys trying it or should we do it here?
Just a minute, ma'am. बस.
Okay.
Ma'am, option one.
Okay, one and okay, let's do this here then. So you have to match these functions with the tangents at 0, 0 and the graph. So we'll come to the graph later. Let's just see the tangent first at 0, 0. So first thing that you have is x to the power x3 to the power x. And then if you will find the tangent, this is your function. So what do you do when you need to find the tangent of a function? How do you find a tangent? Equation of a tangent to a function. Or the general equation.
Ma'am, we differentiate just with that point 0, 0. Find the slope.
Okay. Before that, it's this, right? This is the equation of the tangent.
Yes.
And you need the points here and the slope. So your slope is, for this function, to find the slope, you take the derivative that gives you the general slope at any given point xy, right? So this differentiating this thing gives you x, and 3 to the power x derivative is 3 to the power x, and then natural log of 3, right? Because the derivative of 3 to the power x is 3 to the power x natural log of 3. And then you keep 3 to the power x constant and derivative of x is 1. So this is your derivative. This thing is slope at any given point x. So this is slope at any given point x. And because you've been given the point 0, 0, so you should put x equals to 0 here. To find the slope at 0, 0, you should put x equals to 0 here. That's going to give you f dash x or f dash 0 equals. So this is 0, and this will give you 3 to the power 0, so that's 1. So your slope is 1 at 0, 0, right? So you have m now, and you already have been given the point. So your x naught, y naught is 0, 0 here, right? The point is given as 0, 0 here. So the equation of tangent should be y minus 0, then the slope, which is 1, and x minus 0. So it's going to give you y is equals to x. There are two options for it. Y is equals to x is 2 times here. But in the given options, I think, yeah, 1 is only mapped to B and it's not mapped to C anywhere. That's not a problem. You can, in fact, you don't even have to
Ma'am,
try.
can you explain it
Yeah,
again?
1 second. What?
Can you explain it again? I'm finding it
Yeah,
difficult to understand.
yeah, sure. See, when you have been given C, if this is a function, then how do you find the, let's say you have a function and you have a point 0, 0, right? This is your function. This is, let's say the 0, 0 point is here, by the way, right? This is the 0, 0 point, and you can't actually, this doesn't even cross 0, 0. So let's not include this. Let's just say you have a curve which passes through 0, 0, right? If it's this thing, or let's not even consider 0, 0. Let's just take any random point a comma b. So let's say this is a point a comma b, and you need to find the tangent here at x equals to a. This is your a point, x equals to a, right? So if you need to find the tangent here, tangent means equation of tangent. So this is your tangent. How do you find it? Equation, your tangent is a straight line, right? And equation of straight line is y minus y naught equals x minus x naught m times, where your m is the slope of this tangent line of the given line, and x naught y naught is the point that it passes through, right? So it's given to you that this passes through 0, 0 because you're finding the tangent at 0, 0. So the point is 0, 0. So your x naught y naught is 0, 0, and the slope is, slope you have to find of this line. So this is a straight line. You have to find the slope of this line. How do you find the slope of this line? Now, to find the slope of any line or any curve at a given point, slope also you have to find at 0, 0, right? Slope of f at 0, 0. Because we know that the slope of this line at this point, this tangent line at this point, and of this curve at this point is the same. This is a point where this line and this curve meet. That's the only point common in this line and this curve, right? So the slope
Yes,
at
ma'am.
this point and of this curve and this line is same. So your slope of f is given by f dash x. This gives you general slope. General slope means this gives you slope at any point x. And f dash 0 or f dash a gives you, this gives you slope of f at 0, right? At x equals to 0. So to find the slope at 0, 0, you need to put, first you need to find the derivative. This is your derivative. Do you want me to tell how you find the derivatives of functions?
Yes, ma'am.
Okay. So this is all. Let's just first focus on what we have to do. Then we'll come to this derivative. So you find the derivative and put 0 here because we need to find the derivative at 0, right? So you put 0 here and then you will be able to find the derivative at 0. That's your slope at 0. This is slope of f at 0, right?
Yes, ma'am.
Which is 1. And then you plug in all the values here. You know what x naught is, y naught is. We've already written it here. X naught, y naught is 0, 0.
0, 0.
Slope you just found. Slope is 1, right? Substitute all these values, this one and this one here in this equation. And then you will get this one. So this is the tangent, equation of tangent. Is this much clear? Other than how we find the derivative. And about the derivative, let's say your function is x to the power 3x, right? So to find the derivative, you use the multiplication rule. So let's consider this function as gx, this function as hx. So what does your product rule says? It says that the derivative of gx and hx, you denote the derivative by this sign, this dash here. The derivative of the product of gx and hx is equals to derivative of gx multiplied with hx plus hx, derivative of hx multiplied with gx, right? So your gx is x, derivative of x is 1, right?
Yes, ma'am.
So it's 1 here, and then hx is 3 to the power x plus the derivative of hx is 3 to the
3x.
power x and
Yeah.
natural log of 3. And gx as it is, so you'll have x here in multiplication, right? So this is your derivative. Let's remove 1. So this is the derivative of f. And if you'll put, then afterwards we've just put 0 here to find the slope at. This gives you general slope of the function at any random point x comma y, right? And this gives you the slope at x equals to 0. F dash a gives you slope at a, x equals to a. Okay.
Okay, ma'am. Okay, ma'am. Thank you.
Okay. Similarly, you can try it for other functions. So your second function is x, x minus 1 and x plus 1. So to find the slope, what do you do? First thing is to find the slope for tangent. So you take the derivative of this entire thing, and it's easier if you just multiply this thing first. Otherwise, you'll have to apply product rule 3 times. So this is x square minus 1x, and this will give you x cube minus x. Sorry, this is just fx. And then your f dash x is equal to 3x square minus 1. And because the tangent that you have to find is at the point 0, 0, so you put f dash 0 here, you will get minus 1 here. So your slope this time is minus 1. Same thing you do here, y minus 0 equals x minus 0 because your point is still 0, 0, and your slope this time is minus 1. So you get y is equals to minus x. That means this one should be mapped to this one. And this one, because in options it's just b, that's why we're mapping it to b. It could be mapped to either of these, by the way, because they're the same thing, right? But in the options, it's b only. There's no c here with 1. And then you're left with this thing only. That means you can try and find the slope of this too, but it's going to be this only because that's the only thing left. So let's do this one too. This is the same thing with a negative sign, that's all. So it's the same thing with a negative sign. That means your fx will be the same thing with just a negative sign, and your f dash x will be the same thing with just a negative sign this time, right? So if you have minus x, x minus 1, and x plus 1, I don't want to repeat this entire thing again because this function is just the negative of this one. So the slope, this derivative is also going to be just the negative of the derivative of the previous one. So it's this. And then when you do it at 0, you'll get 1. Putting here is going to give you 1 x minus 0. That's your remaining option, right? Y equals x. So this will be your tangent. And then coming to the graphs, the first thing that you have is x to the x3 to the, let's just have the roots of these things. What's the root of this? The known root. It actually has only one root, by the way, because 3 to the power x has no roots. What's the root of this? Okay, it just has one root, x equals to 0, right? What about this one?
0 plus 1 minus 1.
0 and plus minus 1. And this one also has the same roots, 0 and plus minus 1. And then looking, let's just, can you see the graphs clearly? Because this one has two, I just want you to see that this graph and this graph has roots at -1 and 1. These are roots, if you can see it. So this one has a root at -1, 0, and 1. Should I zoom it? Is the graph visible to all, or should I uh,
It's visible, ma'am.
increase this? Oh,
It's visible.
uh, you have two zeros here at in both of these graphs, this one and this one, you have three zeros, one at -1, 1 and 0. And again here you have zeros at -1, 1 and this one. This is where this graph is touching the x-axis. And that means these two have to be mapped to these two, right? But how do we decide? One very easy way to decide this thing is just looking at the tangent. So this one is this, right? One has a tangent y is equals to x. This one has a tangent y is equals to minus x, and this one has a tangent y is equals to x. Y is equals to x line, what does it look like? Y is equals to x line looks like this, right? And your y is equals to minus x line looks like this. Even if you don't know how that happens, if you'll put x equals to 1 here, the value of y you will get will also be positive. So that means if you'll put x positive, you will get y positive. If you'll put x negative, you will get y negative. And in this one, the opposite happens. If you put x positive, your y is negative. Is this thing clear to everyone? So that means your y is equals to x graph looks like this. So for this one, and because the tangent of this one is y is equals to minus x, that means it should be this one, right?
Turned on.
Why second one, it should be this one, right? Because it has a negative, its tangent is y is equals to minus x. So for second one, if the tangent is y is equals to minus x, it should be this one, right? First one. Is this okay?
Yes, ma'am.
Where second is mapped to A and then it's mapped to 1. And then coming to this one. Now this one has this slope. This is the equation of tangent. Y is equals to x. That means it should be this one. Y is equals to x, tangent is this one. So it should be this, right? Is this thing clear?
Ma'am,
It should be
according to
mapped to this one.
tangent, this graph you have told us it is fine, but if we look by the perspective of polynomials like the third function will give us minus x cube plus 1. So minus x cube, that got so confusing. So I thought third one will go with this second.
Okay, let's do it that way then. If that's also one way to do things. You don't have to go there because you have been given tangents, right? So if you're taking this one x minus 1, and x plus 1. And if you draw, so there are roots 0, 1, and minus 1. So it looks like this. This is 0, this is minus 1, and this is 1, right? So if you put a value between 0 and 1, right? So this thing is going to be, if you put a value between 0 and 1, this is negative. 0 and 1, this will be positive, and this will be positive too.
Yeah,
So you're going
yeah,
to
ma'am.
get negative values. It's this thing,
Okay, thank you,
right?
ma'am. Yeah.
So which one matches this? This one matches it, right? Negative value between 0 and 1. Is it
Yes,
okay?
sir.
Okay. And the last one is this. Why you're only left with one graph, and the exponential graph anyway looks like this only. So 3 to the power x curve. Though you should not be deciding it this way because you have x with 3 to the power x. But it should look like this, right? Because it's an exponential curve. 3 to the power x looks like this. And this is the only left option, so it should be this. Map to this, and then it should be mapped to this one. Is this question clear to everyone?
Yes, ma'am,
Can
it's
we
clear.
move on to the next one then? This is the next one.
Yeah.
Give this a try. And if anyone has a doubt in the previous one, we can discuss that.
Ma'am, option 2, 3, and 5.
Okay. 2, 3, and 5. Let's see. So you've been given this function, and you've asked about the continuity and differentiability at 0. 0 is the point of, obviously, that's the problematic point. And everywhere else it's continuous. It's visible that it's continuous everywhere else. So at 0, let's say at y equals to 0, you have to check. Let's first do the continuity part. So your f0 is 1, right? For continuity, you want f0 equals fx when x tends to 0 minus, and fx when x tends to 0 plus, right? This is what you
Yes.
want for continuity. So your f0 is 1 as per the, let's me just write down the function first here. It's sine y by y and 1 when y is not 0 and 1 y is 0. So f0 is 1 because the value at 0 is 1. Then for the continuity part, you take the limit, right? So it's sine y. I should have taken y here. Everything is in terms of y. So I have sine y by y tending to 0. Plus, let's do the plus part first. So this is what's this limit?
Ma'am, simple formula 1.
Yeah, it's one, but let's just do both, the right one and the left one. If someone has a problem with it, let's do both. We know that the limit of, by L'Hopital's rule, we know that sin x by x limit exists and it's 1. If someone wants to try it both ways, that I want to find the left limit and right limit both. So what you can do is you can use the plus 1 here first. That's going to give you sin y by y, so it's going to give you 1, and then you can use the other one, which will give you, okay. If everyone is familiar with this fact, then we don't need to do it this way. The limit of sin x by x as x tends to 0 is 1. That means this limit is, your limit y tending to 0 of this fy function is 1. And the limit and the value of the function both are same. That means your function should be continuous here, right? So your f should be continuous.
Yes.
They should have written y equals to 0, but they've written x here. So it should be y here, continuous at y equals to 0. Then this is correct. Then about the differentiability part. So for differentiability, what do you do? First, you find the left-hand derivative. So that is sine. The formula for it is, for the right-hand one, it's f a plus h minus fa by h as h tends to 0 plus. And for the left-hand one, it's this fa plus h minus fa by h as h tends to 0 minus.
No, did it a minus
And
h, so left hand limit.
this is the same thing as this. This okay? These two are same. Either you put a minus sign here and then you take it this, or you take the minus sign here and keep everything positive here. Is that okay? Both are the same thing. This is for left hand limit, left hand derivative, and this is for right hand derivative. But I think everyone is more comfortable with this one, so let's use this one only. And your function is given to be this thing. So if you do a plus h, so it's f0 plus h, right? Minus f of 0. So f of 0 is 1 by h. So this is going to give you 1 here, minus, and f of 0 plus h is fh. And your h is positive, right? That means your fh, and for positive, even if it was negative, the function is actually sin y by y. So you can take sin y or sin h by h as h tends to 0 from the plus side. So this is going to give you sin h minus h by h square as h tends to 0 plus. So you'll find the limit, you'll get 0 minus 0 by 0 here. So it's 0 by 0 form. Let's use L'Hopital's rule then. You will get cos h minus 1 by 2h. If you will then do h tending to 0 plus limit, you are again going to get 0 by 0. So this will again give you 0 by 0 form, because cos 0 is 1 minus 1. So this will give you 0, and then this is also 0, h is tending to 0. So let's use L'Hopital's rule one more time. This will give you minus sin h by 2 as h tends to 0 plus. And this is 0, right? Is this part clear to everyone? That means your right hand derivative is this. Right hand derivative at 0. at y equals to 0. And then for the left hand derivative, you have f0 minus h minus f of 0 by minus h as h tends to 0 plus. Why I'm writing 0 plus here is it's the same thing as mentioning that h tends to 0 and h is greater than 0. Is the equivalent of saying that h tends to 0 plus, right?
Yes, ma'am.
So, and this thing is, so f0 minus h is f minus h. This time your h, the argument is negative. It doesn't matter though. We have the same function for both positive negatives. So you're going to get sine minus h by minus h. And then here you have 1 minus 1 by minus h. So this will give you sine minus h is minus sine h minus h. And then you will have h square. So again, you will use the L'Hopital's rule here because this limit will be 0, this will be 0, and this will also be 0. So it's going to give you 0 by 0 form again. Then you will apply L'Hopital's rule, which will give you this. And then you will get the 0 by 0 form again here. This thing tending to, when h tends to 0, cos h tends to 1. So this will give you minus 1. You have a plus 1 here. This entire thing will give you 0. And then this will also give you 0. Then you will apply the L'Hopital's rule again. So you'll get sine h by 2 this time as h tends to 0 plus. So this will give you 0 again. Does anyone have a doubt in this part? Till this part? So a left hand derivative at 0 is 0. That means your right hand derivative and left hand derivative are same, which means this entire limit exists, right? That means the derivative exists and the derivative is 0. So we know two things now. The derivative exists and it's 0. And derivative is 0. And up here, we have options. So first is fy is differentiable at y is equals to 0, which is true. We just check the left hand limit and the the left hand derivative and right hand derivative at 0 are same. And then the derivative of fy at y is equals to 0 is 0. This is also correct. And this one is then obviously wrong. This is also wrong and this is also wrong. If there's no doubt in this question, can we move on to the next one?
I have one small doubt here. Then that function is given, no? When we are when any function, any type of function is given, and such type of functions when we have to check piecewise, the LHD and the RHD for derivative part only. Then there are some ways, like there are some functions when we can directly like differentiate the function and put the value and check if LHD and RHD is same. But all cases we cannot do that trick. We have to use that formula of LHD and RHD. Can you specifically say where can I like apply that trick and where I have to apply the formula and find the LHD and RHD?
Okay, in questions, these are called branch functions. So if you see a branch function and it breaks at 0, this one breaks at 0 or at any point at A, let's say it breaks at A, then obviously for continuity also you have to specifically check at A, right? And for differentiability also you'll have to check the left hand derivative and the right hand derivative at A. Other parts are going to be fine. Let's say you have a function, so that's typically the case with branch functions. When you have a branch function, then you need to do the left hand derivative, right hand derivative thing. If you have a simple, let's say you only have sine x by x, then there's no problem. We know how to take the derivative of it. And it's the same function everywhere. If you have this function x square plus 3x for the entire domain, then also we know that it's differentiable, right? We can simply use the derivative. We can do this thing, 2x plus 3. We know that this is the derivative. But the problem comes when you have two different functions. Two functions involved or three functions involved. Let's say you have fx here for x between 0 and 1, then for 1 and so these type of branch functions is where you have to typically check these things. Or
Oh, understood.
you don't have to check for polynomials, and there are specifically some functions which we know. The polynomials one you don't have to check. Then the trigonometric ones you don't have to check. Then the rational functions where both are differentiable and the denominator is not 0, that you don't have to check. Then
Potential.
e to the these two functions, these you don't have to check.
Okay, ma'am. Clear, ma'am. Understood.
Ma'am, we don't have to check for derivative also and continuity also both.
These functions are all of these functions are continuous and differentiable.
Ma'am,
Polynomials
I have a
and
doubt. I have a doubt on this question. See, once we find out that this function is continuous, we understand that it's a curve, and I mean it's a smooth curve. So I can directly use u by v method to find the differentiation at 0, no? Sin y by y, u by v.
okay, if this function was just this thing, if you only had sine y by y is equals to fy, then you can use the u by v thing, because we know that this thing is just one. The point is here is when you have two branches here, then the things at the breaking point can change, and that goes for continuity too.
But
So you
here
need to check
we have found out that it is continuous, no, ma'am, already. After finding it's continuous, it's going to be a smooth curve. So
when
I
you take a
directly,
left hand, it's the same thing. Why do you need to check for continuity? Why is the breaking point a problem for continuity? Because you have to find the left hand limit and the right hand limit, and then those two should be equal. That's the same case with derivatives. You have to find the left hand derivative and the right hand derivative. So if your function doesn't break anywhere and it was actually a differentiable function, then it's going to be differentiable because it doesn't break anywhere. You don't have to separately. What's the point of finding left hand derivative and right hand derivative if it doesn't break anywhere, right?
yeah, but I'm just going to ask a little more because I'm still not clear. My question is, what is the difference between the right hand side, whatever you've written, f of y is equal to sin y by y, and the branch function here? Both are almost the same, no? I mean,
It's
not even
both.
almost.
This one, yeah, they're almost the same, but one point, even if you change it, so this function is not defined at 0, right? You can't take y equals to 0 here. And this function is defined at 0. These two functions
Got
are
it.
very different functions actually.
Got it. Got it. Got it. Thank you.
Okay.
Ma'am, actually there is one thing when we find the left hand limit or left hand derivative at a particular point like a minus. So we just have to put the value of a na.
Yeah, you usually just put the value here, like in this one. But sometimes putting the value gives you 0 by 0 form, so that doesn't work. So you will either just have to put the value or you will be using the L'Hopital's rule.
For example,
That will do.
like in this it's like 0 plus, so it should be like 0.00001, but we put 0.
Yeah, you put 0 only, but you can't be putting 0, 0, 0 and all of that because that's a sequence. You can't just possibly try all of them here. You just either you put the value, or if you're getting an indeterminate form, then putting values is not going to work, right? You can't just put values here and find the value of this limit. Can you? That is when you use the L'Hopital's rules. Either you just plug in the value or use the L'Hopital's rule. That's all.
Yeah, for 0 minus and 0 plus, we just substitute 0 only, ma'am. Yeah.
Yeah. Either way, the mod x function is also a branch function. That's why it has a problem in differentiability at 0. Okay. Can we move on to the next question then? We're done with this one, right? Then give this one a try. Let's do this question. So this is the given function, and there are some options that you have to check. So first
It's
thing, because
correct.
which one?
Option 2 and option 3 are correct ones.
2, 3. Okay, let's see. So first, every option because involves the derivative. So let's just find the derivative first. So g dash y is equals to 5b5 y to the power 4
y power 4.
to b2y and
Yes.
then b1. Now if you will put, let's just test the first option first. So if you put a 0 here, so g dash 0 is, you'll get a 0 here because you have a y term here. Y is here, 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 and here. That means the only
Yes,
term that
B1.
doesn't have y is this. That means you're going to be left with b1. That means this is correct too. Coming to the second one. So first thing is g dash 1, and then the other one is g dash minus 1. So g dash 1 is
5b5
5b5
plus 4b4 plus 3b3 is 2b2. Right.
if you'll put a negative thing here. So all the even powers will give you just this 1, and odd will give you negative here. It will be minus 4b4 plus 3b3 minus 2b2 plus b1. If you'll just add these two, so we'll be left with 2 times 5b5, 3b3, and b1. 2 times, right? But you have a half here. 2 times this, and then a half here. So it's going to give you this only. And then you have 2 times g dash 0. Let me just write it properly. This is 2 times half here. And then you have minus 2 times g dash 0. So your g dash 0 is b1, right? This will be this entire thing. 2 gets cancelled. So you'll only be left with 5b5 plus 3b3 plus b1 minus b1. So this is 5b5 and 3b3. That's the given option here. That means that's also correct. Coming to the third one, it's g dash 1 minus g dash of minus 1. So you subtract this thing from this thing this time. So if you subtract g dash minus 1 from g1, what do you get? These terms get cancelled, right? The same sign ones get cancelled and the different sign ones remain. These two terms get cancelled. These will add up. So you'll get 4b4, and this will also add up. So 2b2, and these ones will get cancelled. Same sign ones. So we'll be left with 4b4 plus 2b2 2 times. But I think we have a half here. Yeah. And then if you'll put a half here, this is the value of g dash 1 minus g dash of minus 1. If you'll put a half here, you will get 4b4 plus 2b2. That means this option is also correct. And this can obviously not be correct. We're done with this one. This one was an easy question. Does anyone have a doubt in this one? Or so far in what we've discussed? Okay, then let's just move on to this one. Try this question.
Ma'am, I think 86
Yeah, it's
should be
86,
the
ma'am.
answer. Yes.
86
Okay.
meters per minute.
Let's see. So question says this: the distance traveled by car after t minutes is given by the function this. So this is your distance, which is given by this function t cube plus t square
Yeah, it's
plus
also a
t
straight
plus
question.
1. A straight simple question. And when f is
Derivation of this
differentiable,
one, derivating and substituting the value t is equal to 5.
f is differentiable function with the domain r, find the instant. So instantaneous speed is obviously derivative of distance with respect to time. Right? So your speed is uh, ds by dt, where t is time and s is speed. Sorry, distance. Or you can just take u, du by dt instead you can take, where your u is speed and uh, t is time. Right? That's your speed. So to find the instantaneous speed, you need the instantaneous is obviously, we've discussed this thing, right? If you need to find the instantaneous rate of change in the function with respect to the change in variable, and that's your derivative. So you need to find the derivative of this thing. And this is composition of two functions. One is f, and the other function is this one, right? So it's where g is its composition of two functions, where your g is this t cube plus t square plus t plus 1. So how do you find the derivative of this thing? Derivative of f o g is derivative of f, gx in the argument here, and then derivative of g multiplied. So the derivative of f is f dash t cube plus t square plus t plus 1. And then the derivative of this function, because your g is this, the derivative is 3t square plus 2t plus t plus 1. And this you have to find at t equals 5.
Right.
So 5 cube is 125. This is 25. This is 5 and this is 1. So it's 156, right? This total is 156. It's f dash 156 and it's given to be 1. This thing is given to be 1 and then you just find the value of this at t equals to 5. So this will be 3 times 25 plus 2 times 5 plus 1. This is 10 and this is 75. So it's 85 and 86, right? The answer should be 86. Can we move on to the next one if this is clear to everyone? This is the next question. And if possible, try to write this function, although you don't need to, try to write this function in its branch form. You don't need to for this question, but try to.
Ma'am, 41.
Yeah, the answer is 41. Okay, let's do it here. So the function given to you is px equals x. Let's just first write it in branch form only. This function is when you have a mod function fx, then it breaks in the sense that it changes sign at the roots of fx, right? That means if this has roots a, b, and c, then this function is going to change its sign at a. That means at a, b, c, it will change its sign. If it was positive here, then after a, it will become negative. And if it is negative here, then after b, it will become positive. That's what happens with mod fx, right? And you have mod of a polynomial.
Ma'am, when a point is given, can we do one thing that we directly put that point in that px and see if it is positive or negative, then we can understand the behavior of mod function.
You
Like,
can't possibly just check every point. It's easier at the roots of this, whenever you have a function fx, the easiest way to plot the graph or to think of this thing is whenever you have this thing, you're going, how do you plot the graph of, you have been given a polynomial? Let's just first talk about x minus 7 and x minus 8. You can obviously just plug in values and check where it's positive, where it's negative. You can do that, and we'll do that too. While plotting the graph of this thing, you'll need to do that too. But before that, you need to know where it becomes 0. So at 7, it becomes 0. At 8, this polynomial becomes 0. And at 0, it becomes 0, right? So these are the
okay,
roots where that means it touches the x-axis here. And then obviously you'll have to do this thing. So you'll pick up a number between 0 and 7 and then put it here. Because you know that the behavior between, this is a continuous function, right? That means either this function is entirely positive from 0 to 7 or it's entirely negative. Can't change its sign between 0 and 7, right? Because it doesn't have a root between 0 and 7. So you put up any random value here in this function between 0 and 7. So let's just put 1. So you'll get negative here. If you'll put 1 in this function, you will get 1, which is positive. Only sign matters. The number actually doesn't matter. Here you will get minus 6, so it's negative. And here you will get minus 7, that's also negative. So negative, negative, and positive. So the entire thing is going to be positive, right? So here your function's positive. And then obviously, because you have this, and we've done this thing, right? When you have powers 1, that means your function crosses. When you have odd powers, that means it'll have to cross. Now you don't have to test a point between 7 and 8, because we know that this graph is going to cross this point, because all the powers are 1. If you want to, you can just put a value between 7 and 8 and test if it's positive or negative. You're going to get negative only. This will be negative, and then this will be positive. So you can test it in two ways. One is all of these powers are odd. That means it never just bounces back. It will have to cross this x-axis at every root. At every root, this graph is going to cut the x-axis. That's one way to look at it. And the other way is you can just try and put values from 0 to minus infinity. Any value put here, and then see if it's positive or negative. Same do with any value from 0 to 7. Put it here, test if it's positive or negative, and then decide the sign. Then do the same with any value between 7 and 8. So you'll get this graph only. Now, this is the thing. But when you have a mod function, mod fx, now if you have fx as this, that means your mod fx will look like this. Negative side, sorry, if you have this thing, negative side will just come to the positive. So if this was mod fx, if this was fx, then your mod fx will be this thing, this, and then the negative side will be flipped to the positive one, and then you will have this. Is this okay? This one just gets here.
yes,
Is this thing clear to everyone? because we are going to use it here. If this is the graph of this function, then what will the graph of mod of x minus 7, x minus 8 look like? It will look like this thing. Here, here. So here you had this thing. This thing, because it's all the negative ones will just get here on the positive side. That's what mod function does, right? If you have any negative value, it makes it positive. So if you have a negative value here, it will translate it to this point here, right? So here you'll have, this is already positive, so no effect on this one. And then this one gets translated, so it will be this thing here. This is already positive, no change here, and this will get translated here, right? And all the roots of this, if you have, another thing is, if you have mod fx, by graph we can see that this is not differentiable at these 3 points. But even if you don't draw the graph, if you have fx, mod fx, then mod fx is not differentiable at roots of fx. Is that okay? Especially if you have, let's just focus till polynomials. So if you have a polynomial here, px, then your mod px is not going to be differentiable at the roots of px. So if you have, this is a polynomial, that means this thing is not differentiable at the roots of this polynomial. That means it's not differentiable at x equals to 0, 7, and 8. These are the points of non-differentiability for this function px. And your branch function looks like this. It's so from minus infinity to 0 when you have x between minus infinity and 0. Because between minus infinity and 0 here, your function is negative. This thing, x minus 7, x minus 8 is negative from minus infinity to 0. So if you'll put a mod here, it will change sign, right?
Yes, ma'am.
And for x between 0 and 7, it's going to remain the same. Why? Because this time it's already between 0 and 7, it's already positive. So you don't need to change the sign here. So it's x minus 7, and x minus 8 here. And then again, you have a negative part here between 7 and 8. So when you have x between 7 and 8, you should again be putting a negative sign to make the function positive, because between 7 and 8, your function is negative. To make it positive, you put a negative sign. And then after 8, it doesn't matter though, because you have to check the differentiability at 7 only, or at some other point. So you don't have to write this entire thing, but we're still writing it. This will be x minus 7, and x minus 8 only. Is this part clear to everyone?
Yes,
Yeah.
ma'am.
You're putting a negative sign where your function's value is negative, because mod function makes a negative function, makes the negative part of the function positive. So because your function is negative between 7, 8, and from 0 to minus infinity, or you should say minus infinity to 0. So between minus infinity to 0, 7 to 8, your function's negative. That's why you should put a negative sign to make it positive. Because mod function always gives you a positive sign. Okay. And you have to find the slope. So our question is, if m is slope of the tangent of the function at x equals to half. So at x equals to half, you have to find the slope. We didn't need all of this. We just need this one. And then ultimately find the value of m minus half. This is our aim, but let's start from here. So at half, how do you find the slope? Slope is actually the derivative of function. That means the derivative of this. And you don't have to, because we have to find, you would be worried and you will be trying the left hand derivative and the right hand derivative both if these were the end points. If you had to check at 7, 8, 0, that's when you'll use the left hand derivative and right hand derivative. Now you have a point half. And you know that on both left side and right side of half, the function remains same, right? So you don't have to check the left hand derivative and right hand derivative. So you can just simply, between 0 and 7, we know that the function is this. So you can just simply derivate this function. You can take the derivative of this function. And why we're not doing the left hand derivative and the right hand derivative thing here? Can anyone answer that? I already just told this thing, but can anyone answer why we're not calculating the left hand derivative and the right hand derivative separately for half?
Because for both, it's the same function.
Yeah, it's the same function for both, and the left hand side and the right hand side at half does not change. If this is your half, then the function on left and on right remains the same. By left and right, I mean in the close neighborhood, very close to half. I don't mean the entire left and entire right. Obviously, it's going to change when you will go very far away from half, but in close proximity to half, the function is not going to change on either sides, left and right. That's why you can just take the derivative of this. But if you had to find the derivative at 7, then you will have to use left hand derivative and right hand derivative. So the derivative of this thing is, it's x squared minus 7x. What's the product? X squared minus 7x and minus 8x, it's 15x, and then 56. Then just the product with this, so it's x cubed minus 15x squared plus 56x. So this is your function that you should be worried about. Your entire function is this, but to find the slope at x equals to half, you just need this part, right? This part of the branch function. So the slope should be, you just need to take the derivative of this thing. It's 3 x squared minus 15 times 2x plus 56. So it's 3x squared minus 30x plus 56. And then at x equals to half, this becomes 3 by 4 minus
This one.
15, 30 by 2 plus 56. Right? What do we have to find? Oh, it's 3 by 4 only. You have to find m minus 3 by 4. So this is your m. And then your m minus 3 by 4 is 56 minus 15. Right? So it's 41. Yeah, 41. Is this part clear to everyone? Important part is writing this in the branch function form in its natural form so that you can find the derivative of the function, and then how to find the derivative. That's all. Where to use the left hand derivative and right hand derivative, and where to not use the left hand derivative and right hand derivative. By the way, you can use the left hand derivative and right hand derivative at half, but it's useless because we know that it's going to be same.
Yes, ma'am. Even if we see it, the
Just be
graph
wasting time. Yeah.
Thank
So does anyone have a doubt in any of the questions? Because I'm done with the questions.
Ma'am, can you give a recap of these questions?
Of all of the questions that we've discussed so far? Of the last one or of all of these?
All of these, ma'am.
Okay. So here in the first question, you had functions and graphs. So let's just zoom. I'm not going to write anything else now. So this is a given function to you. You've been given some functions and then the slopes, the tangents to it. The tangent is basically, it's a line that passes through that point. So the point is 0, 0, and your functions are these. So if you have x multiplied with 3 to the power x, and you need to find, let's just do this for 1, and then the rest you can understand, right?
Yes, ma'am.
So this one, in this one, for slope, what you do is, there are two things here. One is tangent and the other one is slope. And both of these are different. So slope is basically the inclination of your tangent line, the angle that it makes, the tan of the angle that it makes with. Both of these things are different. Slope is given by f dash x, and the tangent is given by this thing. More
Yes, ma'am. Okay.
precisely, y minus y naught equals to f dash at the point, and, or you should just say, y minus fa equals x minus a f dash a, right? So this is your slope, and this entire equation is the equation of tangent, right? So first you find the slope at 0, 0. This is how do you do it? First you find the derivative of the given function and plug 0 in. So you will find the slope here. And then you put this value here in this function. So there are two unknown things here. First is your this thing, your slope, which we have found here. And the second thing are the points here, A and FA. So A and FA make, one thing to note is A and FA is the point here, which lies on both the tangent and this thing, right? So
Yes,
it's
ma'am.
the point where you have to find the tangent line. It's that point. A comma FA is the point where you need to find the tangent line. So you have all the values here. The point is 0, 0, and the slope we just found here, right? You just plug in the values here. You'll find the equation of that line. That's how you find the equation, the tangents equation in all these cases. And then about the graph looks like this. One of the graphs. So see, one way to do it is you try to plot the graph of the function itself. So if your function is x minus 1 and x plus 1, you can try to plot this is very easy to plot. You can try to plot this function. But you don't have to do it. It's because you've also been given the tangent in this graph, right? So you can use that info. We know that the tangent to this one is to x minus 1 and x plus 1. The tangent is y is equals to minus x. So to this line, your tangent is y is equals to minus x, and y is equals to minus x line looks like this. And y is equals to x line looks like the other, this one. This is your y is equals to x line. So if you have been given, now one of these is this, and the other one is this in the tangent, right? That means the one with this negative slope, this one, is the tangent to this x minus 1 and x plus 1. So where x minus 1 and x plus 1 should have the tangent, should have the graph as this one with the negative tangent, right? Because the tangent here is negative. Is this part clear to everyone? Should I repeat this thing?
It's clear, ma'am.
Okay. And then the same thing you do with the other ones. One very clear distinction, we already know that 3 to the power x is an exponential curve. So it's obviously going to look like this one. And then this has zeros, x at 0, 1, and minus 1. That also helps you figure out which is the graph of which one, right? This
Yes, yes,
obviously
ma'am.
can't be the
Understood.
graph of this one because it has 3 zeros. This has only 1 0. Okay, then coming to the next one. This is your next one. You find the continuity of functions. So for continuity, you just simply find the limit. You know that sine x by x as x tends to 0, limit. This thing is 1. And then the function's value is also 1. So that means your limit of the function, where have we written it? Limit of your fy at y tending to 0 is the same as your function's value at 0. That's why it's a continuous function, right? So it's continuous. And then about the differentiability part, you find the right hand derivative and left hand derivative separately because it's a branch function and it's breaking at 0. So at 0, at all the other points, you don't need to do right hand, left hand at other points. If you are asked the differentiability of this function at 1, then you can just, 1 falls here, right? In this branch. So you can just simply take the derivative of this thing and put 1 in that. That's it. Then you don't have to worry because we know that this one is a differentiable function. At at y not equals to 0, this is differentiable, right?
Yes,
Only
ma'am.
this one, only this part I'm talking about, not the entire function. So about the branch functions, only keep in mind that when you have this thing, wherever your branch breaks, if you have this thing, and then it changes here, and then again changes at C, then you check at these points. This point is to worry about, this point is to worry about, and then this one. All the other points you don't have to worry about. So between A and B, it's continuous because the functions that you're generally given are of this form, polynomial or a rational function, those functions are continuous only. You don't have to check for them. Trigonometric functions, they're also continuous. So you should only be worried about these breaking points. Check the differentiability and continuity at these points. About the differentiability, if it's a point where the branch does not break, then just simply find the derivative and put the value. That's it. But if it's a point where your branch breaks, then find it separately. Left hand limit, right hand derivative, and left hand derivative, do both of them separately. This part okay? Then it's just the formula of right hand derivative and left hand derivative. That's it. We've used just the formula. And both of these are valid formulas for left hand derivative. Either you use this one or your notes and everything says this one. So use this one. No, the other one, sorry. Notes and everything, they make use of this one. So you can make use of this one. Whatever you find easy, you can make use of that one. This one just, we've solved both of these here. That's it. We put A equals to 0 and then just calculated the left hand derivative and right hand derivative. Does anyone have a doubt in this particular calculation? We can do that then. Does anyone have a doubt in the calculation part of this, the left hand derivative and right hand derivative?
No,
No,
ma'am,
ma'am.
no problem.
Okay. Then the third one is, this one's a very simple question. I don't think there should be a doubt in this one. Does anyone have any doubt in this one? Does anyone want to explain this part or again? Because this is just simple taking derivative and putting value. That's it. And same is the case with this one. Just find the derivative and put the value. Only problem that you can have is in finding the derivatives. That's all. And then in the last one, it's whenever there's a mod function or a branch function, its mod function is a branch function only. It's written in compact form, but your greatest integer is also a branch function. Ceiling function, floor function, all of these are branch functions. So first you write them in this form, in branch form, and then you use the left hand derivative and right hand derivative thing. Here, one point that I want to make very clear is at these points are to be taken care of, 0, 7, and 8, because that's where your branch breaks. Everywhere else, your function is continuous and it's differentiable. And you can see the same from the graph. So at 7, you have a problem. At 8, you have a problem. At 0, you have a problem. Everywhere else, it's differentiable, right? It's this. Everywhere else, it's differentiable. Only has problem at these 3 points. Right? So you only have to be worried about the breaking points. That's where you have to find the left hand limit, right hand limit for continuity, and for differentiability, left hand derivative and right hand derivative. But your 2 lies in between 0 and 7. So you don't have to separately test for left hand derivative and right hand derivative. You can just simply use your, there are two ways to find derivatives. One is the direct way using f dash x, right? Let's say you have x square, then one way is to do 2x directly because we know that that's the formula for derivative. And the other way is you do that entire thing. You do fx plus h square minus x square, then by h, and then you take h tending to 0 limit, and then you find this limit. This is a complicated one. Use this only when there's a break in the branch. This is used to find the left hand derivative and right hand derivative separately. Otherwise, you can just directly use the formula for derivatives. Is this okay? Anything else that anyone wants to ask?
I get confused in the derivatives. These simple derivatives I can take out easily, but the derivative thing is still not clear to me very well. The simple ones like these powers and all, I can take it out, but the complex ones create problems.
Which type of questions are you talking about?
Like
The
sine
product rule
cos
one or the
related or the ones that have like
let's do this one.
they are in the fraction form or something.
Is it okay if we take
P
this one?
related length. Yeah.
Okay. Let's start with this one. This is a composition of a lot of functions, right? One is sine function, then natural log function, then square root function. Majorly these three functions, right? And then x square plus 1. So you have four functions there. F, let's call them f, g, h, I. This is for your convenience only. F, O, G, O, H, O, I. How do you find the derivative of this entire thing? First thing is find the derivative of f and put that entire thing here. Don't change it. That means find the derivative of sine, it's cos, right? And don't change the argument. So keep this thing same, right? Then find the derivative of natural log of x square plus 1. That's your next task, right? So this thing is going to be same. For this one, the derivative of natural log of x is 1 by x, right? So for natural log of f, what do? 1 by f, and then you take the derivative of f, right? So we use using the chain rule here. So this will be 1 by square root of x square plus 1, and then the derivative of square root of x square plus 1. Then you come to this derivative, this one. Keep everything else same, and the derivative of, keep this thing here, x square plus 1, and the derivative of square root of x square plus 1, so it's x square. By the way, it's the derivative of root x is 1 by 2 root x. You can just learn this thing. It's this, or you can use that formula, x to the power minus, you're going to do x to the power half, right? Then you'll do half here, x to the power half minus 1. So you're going to get the same thing, 1 by 2 root x. So this thing is 1 by 2 times square root of x squared plus 1. And then the derivative of the inner one, this one, right? So then the derivative of x squared plus 1. Then keep everything constant, just focus on this derivative. So everything else constant, square root of x squared plus 1, 2 times square root of x squared plus 1. And the derivative of x squared plus 1 is 2x. That's it, right? That's how you find the derivative. So do it step by step. First, find the derivative of this. Keep the argument same. Then find the derivative of natural log. Keep the argument same. Then multiply it with the derivative of square root of x squared plus 1. Here, keeping the argument same. Then take the derivative of, that's clear, right? Should I take up one more example? Is this clear, or should I take up one more example on derivatives?
But this one is clear. If you take one more example, that will be helpful.
Okay. So which one do you want me to take? The composition ones only or something else?
Yeah, these ones I find difficult, the composition ones.
Okay. Let's take A to the power tan x, not tan x. Let's take tan, and then let's take natural log of uh, let's take 5 here. 5 to the power tan x, then tan natural log, and then take 1 sec. Yeah. So if you want to take, you want me to take up something special, then you can just suggest. Otherwise, I'll just be taking the same thing, the square root one, the sine, cos. Is there any other difficult function?
There is nothing specific. I just get stuck in the
Okay.
steps sometimes. Yeah.
Let's take 1 by x square plus 1. Let's take this time. This time, let's take this thing. Let's take a square here too. Square is here. So this thing, you start with this. So it's the derivative of 5. Consider this entire thing to be just x. So derivative of 5 to the power x is 5 to the power x only. And as I said, keep the argument same. So keep this entire thing same. Right? And then because you have 5. So 5 to the for 5 to the power x, the derivative is 5 to the power x natural log of 5. So it should be 5 to the power whatever is given and then natural log of 5, right? And then you take the derivative of this entire power. So it's tan natural log of 1 by x square plus 1. Take the derivative of this entire thing, right? Then keep this thing as it is. Nothing to change till this part. Focus on the derivative of this one. This is for tan, the derivative of tan x is secant x, secant square x. So you should take secant square, and here you should take natural log of 1 by x square plus 1, right? And then take the derivative of this argument. Natural log 1 by x square plus 1, derivative of this entire thing. Then keep everything till this part the same.
And the square part is missed out.
Which one? Yeah,
This
yeah. Okay, thanks. We have a square here in natural log. This entire thing is squared, and then we have the derivative of this. To keep everything constant, the same as till here, and then take the derivative of this thing. So it will be 1 by 1 x square. The derivative of natural log of x is 1 by x, right? So the derivative of natural log of, okay, we have a square in this whole thing, right? Let me just write it down properly. This thing is natural log of 1 by x square plus 1 and whole squared. We missed it here too. And then we've missed it here too. Is still this part clear to everyone? Then you just first How do you find the derivative of x square? So for x square, this function is of square, right? That's why we're taking this entire thing as x, and the square, the function is square here. That's why we're taking this entire thing as x. Argument is x. Your argument this time is this. This is the argument of square function.
2
To
times
take
m.
the derivative, take 2 times natural log of 1 by x squared plus 1. Right? This thing. And then multiply with the derivative of natural log of 1 by x squared plus 1. And again, keep everything till this part. This part constant. Constant means same as above. Keep everything same and come to the derivative of this one. So the derivative of natural log of x is 1 by x. So the derivative of this time, only two things you have to keep in mind. What's your main function? Here your main function was square function. Here your main function is natural log of x. So the derivative will be 1 by x square plus 1. It's like this thing. When you have natural log of x, the derivative is 1 by x. When you have natural log of fx, what's your fx here? This is the fx, right? 1 by x square plus 1 is your fx. Then you have the derivative of this. You just replace x by fx. This is your fx is the argument this time, right? Here the argument is x, here it's fx. So you do 1 by fx. And then because fx is in itself is a function, you take the derivative of fx here. Here also you do this thing, natural log of x. So derivative is 1 by x, and then you take the derivative of x here. But that's one only, so it doesn't matter, right? Here if you'll do it, you'll get 1 by x square plus 1, and then the derivative of x square plus 1. So keep everything same as above in this one, next step, and find the derivative of x square plus 1. The derivative of x square plus 1 is 2x, right? That's it. That's where your question ends. Is that okay?
Yeah, ma'am. Thank you.
Okay.
So I need to practice on these what derivative is what, like secant x, etc. So where can I practice those? Where can I memorize those? What is what?
Like the derivatives, I can write down the
Yes.
main derivatives for you.
Yeah. Yeah. Okay. Thank you.
It's some of the main derivatives I've already written in the previous class. Then you have trigonometric functions where your sin x's derivative is cos x. Cos x derivative is minus sin x. Then tan x derivative is secant square x. Secant's derivative is secant x into cos secant. Is it cot x or it's cot? What is it? Let me just check.
Tan. Secant x tan x.
Yeah, thanks. It's tan x. Secant x and tan x. And then the derivative of cot x is cosecant square x. And what's left? Oh, we're left with the secant cot tan cosecant. Cosecant x derivative is minus cosecant x and cot x. Yeah, here we have cot x. Okay. These are your trigonometric functions and their derivatives. Then inverse trigonometric, are you given questions on inverse trigonometric functions also? You can just Google these things. derivatives of inverse trigonometric functions.
Okay, ma'am. Thank you.
Inverse trigonometric functions, I think that's enough. You won't be asked questions from
मैम
anything
cot
beyond
x
this.
मैम cot x minus cosec square x नहीं होगा क्या?
Yeah, it's minus. Thanks.
And how about related to E and related to those are also included in this inverse trigonometric functions,
What about
like the
E?
derivatives of E log ln related derivatives.
The e to the power, we've already discussed the derivative of e to the power fx in the last one, right? The derivative of e to the power fx is e to the power fx, and then the derivatives. We use chain rule here again. And then the derivative of fx, f dash x. And for a to the power fx, it's a to the power fx, f dash x, and natural log of a.
Thank you so much.
Okay. Anything else anyone wants to ask? Else we can just wrap up the session.
Ma'am, I have a doubt in week 7 graded assignment.
Yeah, 1 second. Let me just open the graded assignment first.
Question number 10.
1 second, 1 second. Okay, right. Week 7, graded assignment, question 10. Okay.
Ma'am, a little doubt in the question number 3, ma'am, that you.
Of the same graded assignment 7.
No, that you solved today. The calculation part of that.
Okay. 1 sec. This is the question you're talking about, right?
Yeah, but 10 is something
Yeah.
different.
10 is a sub question to this one only, right?
Yes.
Ma'am, what you have written, like it remain in your system, like
in the next class also? Because if I just get back and revise all of it, and if I wanted to ask something, can I ask in the next class after revising all of
Yeah,
it?
yeah,
Like,
it's on my system.
okay, so I'll revise all of it once and twice, and I'll ask maybe in the next class. Is it fine, ma'am?
Okay, yeah. Next class is the revision class, by the way. So I won't be taking that class.
No, ma'am. Whenever there is a next class,
Yeah,
a little
okay,
nitty-gritty doubts, ma'am. Not all of it.
okay.
Yeah.
This question is, it says a company runs 3 algorithms to estimate its future growth. Suppose the error in the estimation depends on the available number n. So this is error in the first algorithm, this is second, and this is in third, where your n is, it's depends on the available number. Okay. Suppose the company has a large amount of data in hand, we can assume n tends to infinity. Using the information given above, answer the question. So this is the question that you have to answer. Suppose the company modified the error in estimation by algorithm 3 as, let's say they have modified it to this one. Previously they had something else. Now they decided to take this one. Previously they had this e to the power n plus 4 by 7 e to the power n. What will be the new error in estimation by algorithm 3? Error in estimation by algorithm 3. Just 1 second. So this is about the limits thing, right? You have to find the limit when limit n tends to infinity.
Yes.
So this is n e to the power 1 by 10 n minus 1, right? So if you take this as n tends to infinity, this tends to infinity. As n tends to infinity, this thing tends to 0. This is going to tend to, this is 0 into, I've already discussed this and I've told it here that this is an indeterminate form, right? So how do you deal with it? You take the, okay, you use the L'Hopital's rule for these cases. How do you use it? It's e to the power 1 by 10n, and we are familiar with the 0 by 0 forms and infinity by infinity forms. So let's just make this form into this form only first, right? So you have this, and then instead of n, let's take 1 by n. It's the same thing. Now if your n tends to infinity, this thing goes to 0, and this thing goes to 0 too, right?
Ma'am,
Yes,
why are
ma'am.
we using L'Hopital's rule in week 7 graded assignment? The rule is
Can
from
be
week
done
8, right?
using, yeah, is it not there? Okay. If it's not there, then
You can take the denominator as 1 upon 10 and then get it in the,
And
we'll get constant 1 upon 10.
it will be 0.1.
if we're not supposed to use the L'Hopital's rule, then
We have an identity e power x minus 1 by
E
x.
raised to x minus 1
yeah,
upon
thanks
x.
for
That is
reminding
what it
me.
is.
And sorry for forget that I forgot it. It's we have an identity e to the power x minus 1 by x, right? Where x tends to 0, and this gives you 1. So this is the same identity. So you can just, we already are in that form only. So 1 by 10n minus 1, and this will be, we already have 1 by n. Just multiply this by 10, and then you'll have to multiply it here too, right? To keep everything balanced. And then as n tends to, taking it tends to infinity. Let's just check this too. E to the power x. If you have this thing, then you should be taking e to the power This is when you take x to the power x tends to 0. Have you
Yes,
done
1
this?
upon
There
n
is,
tends to 0 if x tends to.
yeah, this one we have n tends to infinity here, and this will be, we have n tending to infinity here. So we can just take 1 by n tending to 0. When your n tends to infinity, 1 by n tends to 0, and this is minus 1 by 10 into 1 by 10n. So this entire thing, this thing, goes to 1, and then you have a 10 in denominator, so it should be 1 by 10.
Is equal to 0 till 1.
Is that okay?
And whenever there is a limit n tends to infinity and we want to change it, we can directly change to like 1 upon n tend to 0.
Yeah, when n tends to infinity, because if you have this, n is natural numbers, right? So when you have natural numbers, if your n tends to infinity, your 1 by n tends to 0. You can directly assume that if your n tends, or not assume, it's actually true. When your n tends to infinity, then your 1 by n, it's this 1, 1 by 2, 1 by 3, and so on, so on. This sequence tends to 0. Because each time you're increasing the denominator and making the number smaller and closer to 0. Is that okay?
Yes, ma'am, got it.
And there is one more, you said one more indeterminate form, that is infinity minus infinity, na? If that comes, then what can we do? We can use L'Hopital rule also then.
The L'Hopital rule is what you're supposed to do, but do we have questions on infinity
No,
minus infinity form?
I don't think, ma'am, but in general, I was asking if suppose.
You just convert it to 0 by 0 form first, or infinity by infinity form first. And then you use the L'Hopital's rule.
Ma'am, well, if the form is 0 by 0, we use L'Hopital rule. And after using that rule, if we get a 1 by 0, then the problem ends there, right? It's infinity. Is that right,
Yeah,
ma'am?
then the limit is infinity.
Okay, thanks, ma'am.
Okay. Anything else? Okay, then I think we can end the session here then.
Okay,
Bye.
ma'am. Thank you, ma'am.
Thank you, ma'am. Thank you very much.
Ma'am, question number 4, can we discuss today or maybe next time if?
Which fourth?
The one you discussed today.
Yeah, we can do it now. What's the doubt?
Yeah.
This one is the fourth one.
Yes, ma'am.
You have a problem in this one?
Yes, ma'am.
What is it?
Like, how did you create FOG here, and like, how did it happen?
This is the function given to you is ft cube plus t square plus 1, right? And this is a function, and then the argument is also a function, right? We're used to this thing where your argument is just x, but now you have, or just t, but now you have a function in argument. That means this is another function. Let's call it function g, right? And how do you find the derivative of this entire thing? F composed with g. First, you find the derivative of f and keep gx as argument of f. And then you find the derivative of g. So in this case, your f is, we don't know what f is. So let's take f dash and gx we keep here in the argument. So it will be t cube. By the way, we should take t here, gt and g dash t. T cube t square plus 1 plus t plus 1. And then you take the derivative of this function, the argument function, right? So you should take the derivative of t cube plus t square plus t plus 1. This is going to give you f dash t cube plus t square plus t plus 1. And then just the derivative of this thing, which is a simple polynomial. So it's 3t square plus 2t plus 1. Is that okay? This is also a function. So whenever you see f and you don't see x, instead you see a function here, some other function. Let's say you see h or some other function, sine x, and then other cos x. That means unless your argument is not x, you don't stop differentiating. You keep differentiating. So if you have f, g, then h, x, then the derivative is going to be f dash g of hx. Then take the derivative of g dash hx. Then take the derivative of h. So it's h dash x. And then in the argument, finally you have x.
So
You
ma'am,
can take the derivative of x, but it's
we
1
were-
only. Yeah.
So ma'am, we were double differentiating it because it was first like the function was in terms of distance, then we have to find it in terms of speed.
Yeah.
We are double differentiating it in that way,
No,
na?
we're differentiating it only one time. The derivative involves multiple derivatives. First, you find the derivative of f, then g, then
No,
h,
no,
and if
no.
there's one more,
The function involve that whenever the function involve the dependency of time with distance, na?
yeah. So it's to find speed, you only need to differentiate it once. Differentiate the distance once with respect to time. That's it.
So we should have just differentiated like once, na? Why we are creating FOG? I didn't got that.
We're not creating FOG. If that's
It is in
causing
the
you
FOG
trouble,
form.
it's just it's in the FOG form only. If that's causing if someone who's used to finding derivatives is not going to write g here. They know that first you find f the derivative of f, and then you find the derivative of the argument of that function. So here we're not differentiating it twice or thrice. We're just completing the derivative once. That's all. This is differentiated one time only.
Okay, so
This
the differentiation was 3t square plus 2t plus 1, and then we put t5 here in the calc. I was saying that.
Just put t5 and then you'll find the solution. That's it. Is that clear? Does anyone have any other doubt?
No, ma'am.
Okay. Then
Just before this, there was one other question. Na? Just when you were solving this, there was just before this.
this one?
Just before this. Yeah. The calculation part of it, I had this.
Okay. The function is sine x by x, right? So put instead of x, put h. You will get sine h by h minus f of 0 is this. At 0, your function is 1, right? Put 1 here. And then h. And then take h tending to 0. We've already discussed it a lot of times. H tending to 0 plus or h tending to 0 when h is greater than 0. These two are the same things, right? I've written it in different manner. That's all. It's h tending to 0 plus. And then you just find the limit. We've just simplified this in this form. Take this h here. You'll get sine h minus h by h. And then whole thing divided by h. So it gives you this.
Yes.
And then you've applied L'Hopital's rule twice because you'll get 0 by 0 form twice.
Okay.
Then the same thing we've done here.
For 0 plus.
Yeah. for 0 minus, for the
Hmm.
left one. This is for the left hand derivative.
Okay, and we got the same value, both of them.
Yeah, you got the same limit here, 0. The limit is same.
Okay, just if we can just get back to the question once, this one. Okay, so it was saying that it was continuous at 0. Okay.
So session is done, no? You can leave.
Is that
So for the
is everything clear?
Ma'am,
Yeah.
actually, I have to just like see it full once, or maybe you can explain it full once, or I'll get back in the next class. It's your choice, ma'am. That's it.
So, is it okay if I just do this left hand derivative part?
Yes, ma'am.
Okay. It's let's just quickly do this thing. You have sine by y. You can also take x here. We're more comfortable with x, so let's just take sine x. Sine x by x, fx equals to sine x by x and 1 when your x is not 0, and this is when your x is 0, right? And you have to find the left hand derivative of this function. So left hand derivative's formula is left hand derivative of f at x equals to a. How do you find it? It's f a minus h minus f of a by minus h, as h tends to 0 plus. 0 plus means approaches 0 from the positive side, right? So what's your f? So for f a minus, and you have to
That
find
is
the left hand derivative
0
at
minus
0.
now because it's a left-hand derivative.
We've taken minus here.
Okay.
Minus and minus. So at 0, it will be f0 minus h minus f of 0 and minus h, as h tends to 0 plus. Now your f of 0 minus h is, we know that h is, or minus h, whatever this thing is, it's not 0, right? Your h is tending to 0 from the positive side, but it's not 0, right? So if the function's value at a point which is not 0 is sine x by x, that means this should be sine h by h, right? Your argument is h here, so you should take h, sine h by h. And then at 0, the value is 1. So it should be 1. And then you have minus h here. And it's actually, because it's minus h, you should have taken minus h here. Minus h. Now your sine minus h is minus sine h only. And minus h. So these two gets cancelled. You have minus 1 here. Minus h tending to 0 from the positive side. So this is sine h. We're just simplifying this expression, h by h. This is going to give you sine h minus h by h square, as h tends to 0 from the positive side.
In the
It's actually going
denominator,
to be minus h
minus h,
square.
no?
Yeah, it's not going to matter because your limit is 0. So if your function's limit is 0, and if you put a minus there, it still be 0. That doesn't mean you should be making mistakes
What,
in the
ma'am?
questions.
Last point, what did you say?
If your function, let's say your fx is going to 0, right?
Hmm.
And your minus fx will also go to 0. So if I miss a minus sign here, this entire thing goes to 0. It will, you'll see. And minus of that will also go to 0, no? So it's not going to matter, but you still should do the right thing. This is correct. And then this is 0 by 0 form. If you will put 0 here, you'll get sine 0 as 0 minus 0 by 0, right? So this is 0 by 0 form. You differentiate it once. This is cos h minus 1 by minus 2h. And then if you put, this is h tending to 0 plus. So cos 0 is 1. This is minus 1. And this is 0. This again makes it 0 by 0 form. So you differentiate it again using L'Hopital's rule. So you'll have minus sine h here this time and minus 2 here, right? As h tending to 0 plus. Now, if you miss, I think I've missed one of those signs there. Even if you miss a sign here, it's fine because this is ultimately going to 0 only. When h tends to 0, your sin h also tends to 0. So this entire thing will go to 0. That means your left-hand derivative of f at x equals to 0 is 0. And same goes with the right-hand derivative. Is that okay?
But for the left hand derivative, why did you took 0 plus? It should be 0 minus, is it?
No, it's 0 plus only. In the definition, it says, the definition says this. FA, I think it's this. Where your h tends to 0, it just says this thing, right? But it mentions that your h is greater than 0. Separately, it mentions that your h is greater than 0. So when it's given that your h is greater than 0 and h tends to 0, this means your h is tending to 0 from the positive side, right? If this is 0 and your h tends to 0, so your h can tend to 0 from here and here. But you have mentioned that your h is greater than 0, that means your h tends to 0 from this side only.
But it's left hand derivative now, so we should approach from left hand side.
If you will approach, that's a different form. If you want to approach from left, just do this thing. And then approach from the left one. Is that okay? These two are same things.
The confusion, because sometimes here it is 0 minus, it's left hand derivative, and above also.
That's why forget this one. Don't keep this in mind. Because the notes and everything that you have, use this one.
By default,
so just use this one.
By default, it is used like that in a way. Okay.
The other one is also the same as this. This limit and the other one is the same thing. But because in the notes and everywhere, the one that I took screenshots of, it uses this formula.
But by the definition, it should be like left hand derivative. We are approaching it from left.
That's why we have, when you find that your derivative is this. By h as h tends to 0. Now this does not mention whether h tends to 0 from the plus side or from the minus side. So this is then bifurcated into two parts. This is derivative, bifurcated into left-hand derivative and right-hand derivative. So for the left-hand one, you take this expression. Let's call this thing n. Just give me 1 second. Yeah, so for the left hand one, for the right hand one, you do this thing. Fa plus h minus fa by h as h tends to 0 from the positive side. And for this one, you do fa plus h. Okay, how do you find the limit? If you have fx as x tends to 0, let's say, then how do you find the limit of this thing? You do f 0 plus h as h tends to 0 plus for the right hand, right? And for the left hand, you do f0 plus h as h tends to 0 minus. It's the same thing that we're doing here. So for the limit, you do this only. H as h tends to 0 minus. And if h tends to 0 from the negative sign, that means your h is negative, right? What does this mean? That your h tends to 0 and your h is negative, right? So instead of taking, and this h is positive actually, this one that you're, or whatever it is, even if it's negative, what you can do is instead of taking h, so now you have h which tends to 0 and it's less than 0. So do this thing, replace it with k minus fa by k. Or just say, how do I put it in simple words? Just replace your h with minus h. Can we do that here? Replace h with minus h everywhere. It's like this thing, 0, h tends to 0, and h is greater than, less than 0. Wait. Instead of this, let me just write this thing down here, because it's the same thing, right? H tending to 0, and h is less than 0. Now let's just change the sign of h. So you'll have f of a minus h, minus f of a, minus h, where, because you've changed the sign of h. Previously it was negative, now it should be positive, right? Is that okay?
Why
That's why these two. If you
because
have, yeah, because you're changing the sign of h everywhere. Change the sign of h here, change the sign of h here, and change the sign of h here too.
okay.
Because here you have h negative. Now you should be taking positive, right?
Okay.
That's it. So to avoid confusion, just keep this thing in mind. This one. Okay.
So you solve it by the below what you have written through that.
Yeah, I've used this one.
But practically, when we solve it, when we approach something from the left hand side, yes, ma'am. So in a way, it is. We are saying it by calculating it. We are saying it like just replacing the sign. That's all, I guess. Because
Maybe
here we
just
are
replacing the sign. That's it.
a little complicated, ma'am. A little bit, just maybe.
That's why I told you to just keep this thing in mind. Don't get into all this. Just keep this formula in mind for left-hand derivative. That's all.
In a way, both the negative sign get cancelled, so we can say that
Yeah.
h more than 0.
Here both of them get cancelled.
Yeah, the below form that you have written here, in a way, the negative sign get cancelled from numerator and denominator. So in a way, we can say that h is more than 0. That's what you are saying,
Yeah.
na? So it's just a form. Actually, I am clear on that, but the form that is that you are culminating into, I just had a little bit confusion on that. Because whenever I see a question, I wanted to see like from the beginning till the end and how it is done, each and every step. So I just thought that practically how it is possible when I am approaching it from left hand side. So I thought, okay, numerator and denominator sign got cancelled. So in a way, we are saying that, okay, I don't know. I think I have got it.
Okay. Anything else? Else we can just end the session. Okay. Thank you for joining, guys. Bye.
Thank you, ma'am. Thank you.